everybody again. So today we're finally going to do the practice section. Let's start. Exercise 12.5. Find the median, quartiles, and interquartile range for each of the following. Make sure that you show your method clearly. So the median is 6, the lower quartile. For A, the median is 6, the lower quartile is 4, the upper quartile is 9, and the inner quartile range is 5. For B, the median is 17, the lower quartile is 12, the upper quartile is 21, and the interquartile range is 9. For C, the median is 14, the lower quartile is 5, the upper quartile is 18, and the interquartile range is 13. For D, the median is 3.4, the lower quartile is 2.45, the upper quartile is 4.95, and the interquartile range is 2.5. And finally, for E, the median is 15.65, the lower quartile is 13.9, the upper quartile is 18.42, and the interquartile range is 4.53. Applying your skills. Try to think what the calculations in each question tell you about each situation. Question 2. Gideon walks to work when it is not raining. Each week for 15 weeks, Gideon records the number of walks that he takes, and the results are shown below. Find the median, quartiles, and interquartile range for this data. Question 3. Pavan is conducting a survey into the traffic on his road. Every Monday for 8 weeks in the summer, Pavan records the number of cars that pass by his house between 8 a.m. and 9 a.m. He then repeats the experiment during the winter. Both sets of results are shown below. Find the median number. Wait, did I say the answer for this yet? Oh, okay. The answer is 6. The median is 6, the lower quartile is 4, the upper quartile is 8, and the inner quartile range is 4. Okay, for B. Find the median number of cars for each period. Find the inner quartile range for each period. What differences do you notice? Try to explain why this might happen. So, for A, the summer's median is 18.5. The lower quartile is 15.5. The upper quartile is 23.5. And for winter, the median is 11.5. The lower quartile is 9.25. And the upper quartile is 12.75. So, for B, the interquartile range for each period for the summer is 8, and for the winter it's 3.5. And for C, the lower IQ interquartile range in winter shows that car numbers are more consistent. In poor weather, people either use their own transport or take transport more consistently. Question 4. Julian and Anish are reading articles from different magazines. They count the number of words in a random selection of sentences from the articles, and the results are recorded below. Julian, reading the statistician. Forget about it. Anish, reading the algebraist. So calculate the median for each article. Calculate the interquartile range for each article. Anish claims that the editor of the algebraic has tried to control the writing and seems to be aiming it at a particular audience. What do answers from A and B suggest about this claim? So, for Julian, the median is 23, the lower quartile is 13, and the upper quartile is 24. For Anish, the median is 18, the lower quartile is 14, and the upper quartile is 20. The inner quartile range for both is 11 for Julian and 6 for Anish. So here, the IQR for the algebraic is more consistent than that for the statistician, and there is therefore more likely to have a particular audience, while the variation is greater for the statistician, and therefore can appeal to a varying audience. Question 5. The fuel economy, kilometers per liter of petrol, of 18 new car models was tested in both city traffic and open road driving conditions, and the following stem and leaf diagram was produced. So, find the range of kilometers per liter of petrol for city traffic and open road conditions. Find a median fuel economy for city traffic and open road driving. Determine the inner quartile range for city traffic and open road driving. And finally, compare and comment on the data for both city traffic and open road driving. So for A, the range is 6.5 for city traffic and 5.9 for open road conditions. For B, the median is 10.85 for the city traffic and 14.05 for the open road. For C, the inner quartile range, it is 3.275 for city traffic and 3.65 for open road. So, at first glance, it seems that country driving gets much better fuel consumption, as it appears that the data is distributed more towards the higher end of the stems. However, the smaller interval and the decimal nature of the data mean that when you look at IQR, the inner quartile range, there is not such a massive difference in consumption, given that the only difference between the two IQRs is only 0.375. So that's the end of this video. Thank you and goodbye.